My name is Atta-ul-Latif Khawaja, and today I will discuss the paper 2, question paper 2 from the Cambridge International Examination. Uh, this question paper is October November 2018. Uh, Paper number is this 970222 because yeah, this is a question paper 2. Uh, question paper one is related to the multiple choice, and question number two is related to the theory. And this is October, November. O represent the October, N represent the November, and 18 represent the 2018. The total time given to student is 1 or 15 minutes to solve. I will solve this paper with complete detail and description. Uh, so let's start from the question number one. Uh, Question number one is about the a golfer strike a ball so that it leave horizontal ground uh, uh, with the velocity is equal to 6 meter per second at angle theta. This angle theta is along with the horizontal as shown in figure. The magnitude of initial vertical component is also given, that is 4.8, assuming that air resistance is negligible. I mean, we consider there is no air resistance. So, what is A part? Show that the magnitude of initial horizontal Vx. We have to find the uh, horizontal component, initial horizontal component. As from diagram, you can easily observe that uh, the v velocity, initial velocity vi is given, that is 6 meter per second. So because it is making angle theta with the horizontal, so it will have a two component. One is vertical and one is horizontal. Vertical component is given, that is equal to Vy is given, that is 4.8 meter per second. Now we have to find the Vx. Uh, since this is a and this is a right angle triangle, so by using the formula for right angle triangle, that will be v square is equal to vx square plus vy square. We can find the value of vx. Vx square will be equal to v square minus vy square, because v is given, so uh, we uh, we will have vx square will be equal to vx is given, sorry, v is given, that is 6 square minus 4.8 square. So by taking the square root both side, we will get the required result, that is 4 that is 3.6. So the result will be 3.6 meter per second. Okay, so this will be the required your result. This was the A part. Now we move toward the B part. B part is ball leave the ground at t equal to 0. Okay, so and reach its maximum height t equal to 0.4 second. In figure 1.2, sketch the in a separate line to show the variation with time until the bar return to the ground. Okay, ground off. The vertical component, we have to find the, firstly, we have to find the vertical component, and it will be representing by the line y, and then will find the x component that will be representing by the x. Okay. As according to provided data, initial velocity, vertical velocity. Firstly, we have to find the first. Okay, at time t equal to 0, uh, Vy is vertical velocity is given that is 4.8. Okay, so this is vertical velocity at t equal to 0. Initial vertical velocity, that is mentioned that this there is initial vertical velocity. Okay, so initial at t equal to 0 velocity is 4.8. Okay, and at t equal to 0, sorry. So I may write it because velocity is along the y component, velocity is along the y axis, and time is along the x axis. This is velocity v, and along the time axis, that is t. So uh, and at t equal to 0, equal to 0.49, it reaches the maximum height, at maximum 0.49 second, uh, it reaches the maximum height mean the final velocity vertical component will be 0, so Vy will be 0 at this 0.2, because at maximum height, vertical velocity will be 0. Okay, so if I take the time axis with 0, then we will get the pair coordinate as 0, 4.8, and the after time second time is 0.49 second. Vertical component final vertical velocity will be a 0. So 0.40 and 4.8. So 4, this is 4, 1, 2, 3, 4. That will be a uh, at 0, that will be a 4.8. Okay. The this will be a 4.8. Okay. And the second is uh, 0.4 x-axis, along x-axis, the value is 0.49 second, and final velocity is 0, vertical velocity is 0. So 0.48. So this will be a 0.48, and velocity, because velocity is 0. So here this is a 0, 4.8, and this point coordinate will be a 0.49 and 0, because y-axis will be a 0. But so if I join these line, sorry, this is not, because I don't have a scale. You must use the scale during exam. Okay, but When the ball reaches at the maximum height, it will return with the same velocity but in opposite direction. So if I consider that this velocity is 4.8 at maximum height, that is positive, then it will be reduced to the sorry the magnitude will be remain the same, but it will move toward the negative direction because direction is changing. So the value, the sign of the velocity will be reverse. So that's why the velocity, the x-axis will be increase the same value with the but with the negative sign. So when it reaches the ground, it will take the 0.49 second. Okay, 0.49 second to reach the ground, because when we double the 0.4 sorry so so total time will become 0.49 0.49 plus 0.49 98. So at 98 98 second, so here the time will be not of one complete 1 second, but it will be a 0.98 second. So it will reach the so the that will be the value will must be a coordinate value will be uh, second graph will be second will be a 0.98 and negative 4.8 velocity. Yes, negative 4.8. So this is a 98 and this, so this so we will join this. So we will have this and this graph because he said that it must be labeled with the y, so I label it with the y. Okay, for second part we have to find the horizontal component Vx, and it must be labeled with the, as horizontal velocity is constant because there is no variation in horizontal velocity. Uh, Horizontal velocity is 3.6 and 3.6 per second, and this will be a constant. That will be no there will be no variation with respect to time. So 3.6 I have to consider. I will zoom in. Okay, for 3.6, 1, 2, 3. This will be a 3.6. Each box will be represent two digit. So point two. Okay, so 2, 0.2, 0.4, 0.6. This will be a 3.6, and this will remain the constant. There will be no variation with respect to time. So this line will be parallel to the this line will be parallel to the horizontal horizontal line. So that will be the uh, and that will be remain for all time. For all time, this the velocity value will be remain 3.6. Okay, so this will be your required result. Okay, and that will be a graph for 2. And if I represent, he said that it must be labeled with the x, so I must label it with the x. Okay, this graph. So for y, this, and second for x, you will have the change in coordinate that will be remain the same, t to 3.6 for all value of t. There will be no variation. Okay, So this is the answer of these two. Now we have to calculate the maximum height reached by this ball. Okay, initial velocity is given maximum height because we have to find the maximum height. Question number C, the maximum height. So we have to find the maximum height. And this maximum height mean this is a projectile. This will be a maximum height. Okay, we have to find this. Okay, so to solve this, mm, we will consider only the vertical component as S will be equal to H for vertical displacement because if we are interested to find the distance covered, then we have to find the horizontal distance. But now we have to use the vertical component to find the maximum height. As we know, there are different formulas for to find the maximum height. So firstly, I will prefer that we may use that for vertical S equal to 2A S equal to VF square minus VI square. Okay, since at here vertical, so for vertical velocity, so for vertical, we have to consider the vertical final velocity, that will be a zero, and initial velocity, vertical initial velocity is given. Okay, why? Since to find the maximum height, we have to consider the vertical displacement. So we have to use the formula that will be 2s equal to vf square minus vi square, where a is the acceleration. That vertical acceleration is there is only one acceleration, that is a vertical, and that is due to the weight, and that is the gravitational acceleration. So A will be equal to G, and that will be equal to minus 9.8 meter per second. Okay. And VI, because VI will be equal to initial vertical velocity is according to Y, this graph, with 4.8 at t equal to 0, initial velocity. But initial vertical velocity is 4.8, and final velocity, because at maximum height the ball will be stopped, so final velocity will be a 0. By putting these all these value, you will get 2 minus 9.8 multiplied by S. VF is VF is 0, 0, so 0 minus VI is 4.8 here. Okay, negative sign will be cancelled with the, so the S will be a 4.8 square divided by 2 9.8. So by calculating all these, that will be approximately equal to 1.2, yeah, 1.18, or you may say that that is 1.2 meter. Okay, you may also find this by using this formula You may find this by using this formula, or alternatively, there are many different formulas. As for example, you may use the VIT plus 1/2 GT square. You may use also you here initial velocity is given, that is 4.8 uh, time to reaches the maximum height is that is given 0.49 plus 1/2 minus 9.8, or you may say and t is again 0.49 square. So you also may use this formula too, or if you are the result will be the same. If you are interested to, you may also use this formula too, s equal to 1/2 average velocity vi plus vf, or t square t. Okay, so 1/2 initial velocity is 4.8, and t is vf is 0, as we know that vf final velocity at the maximum height is 0. So t is 0.49. The result will be the remain the same, 1.17 or 1.8 or 1.2 meter. Okay, so all these formula may be used. So the maximum height will be a uh, ball will be a 1.2 meter. Okay, so next question is B part. What is the movement of the ball from the ground to maximum height? Determine the ratio. Kinetic energy of maximum height. Uh, as we know that final velocity is 0 at maximum height. So kinetic, to find the kinetic energy at maximum height, to find the kinetic energy, firstly we will find the kinetic energy, that is 1/2 m v square. So at maximum height, we know that vh at maximum height vy will be a 0 at maximum height. So we have to find the kinetic energy at maximum height. So I think I should write it here. The kinetic energy at maximum height. So at maximum height, kinetic energy formula is we know that mv square. But as we know that v y at maximum height will be a 0, but vx will be at vx I have already, that will be a constant remain to, because that will be remain the constant as given 3.6. So that will be a, sorry, that will be a 3.6, 3.6. So this implies that v equal to vx square plus as we know that v is equal to uh, vx square plus vy square. V square equal to vx square plus vy square. Uh, 3 point, that will be a 3 square of the 3.6 plus 0 square. So this will be v, and that will be on when we take this square of the, that will be so the kinetic energy will be equal to, from this formula we may find the kinetic energy, that will be equal to 1/2 uh, m m 3.6 square, that will be equal to 4.6.48. Okay. So 6.4 m multiplied by mass, because mass is not given, so we will multiply it with the mass value. When we take the square of the 3.6 and divide it with the 2, that result will be a 6.48 multiplied by mass. Okay, and so now we have to find the potential energy, gravitational potential energy, that is uh, gravit G gravitational potential energy. That will be equal to mgh, as we know that that will be mgh, and value of m again unknown. 9.8 is and height, maximum height, I have already calculated, that is 1.2. Here is 1.2. Okay, so 1 point round about 1.2. So the potential energy approximately will be equal to potential energy approximately equal to 11.517 mass. Okay, okay, and with multiply of the mass. Here mass is multiplying with the both. So when we divide these two value, so so the ratio will be kinetic energy is was the 4 point sorry, okay, what was the value of the kinetic energy? 6 point, sorry, connecting 6.48 will be divided by 11 point, okay, 11.578. So result will be equal to 0.563 multiplied with the mass. Oh, no, sorry, mass will be cancelled. Here is a mass and here is a mass. This mass will be cancelled. So result will be the joule. Okay, mass will be cancelled with each other. Okay. Oh, sorry, not joule, because the joule will be cancelled with the joule, and so this will be a ratio only. Not, there will be no unit. Okay, so the result will be so answer will be uh, 0.563. Okay, you, because it is a ratio between two joule, this two physical quantity have the same unit, so that will be unit will be cancelled, so this will be only the ratio, and this will be independent from the its unit. The next question part is E, and it is about the, in practice, significant air resistance effect on the ball. Explain why the actual time taken for the ball to reach maximum height is less than to the calculate when the air resistance is assumed to be negligible. This is a very surprising question, actually, and it is a very confusing question. Actually, when mass move, sorry, uh, actually, when ball will be move upward, the force will be velocity will be upward. Okay, uh, but their acceleration will be a downward. G acceleration will be a downward, and it will be reduce its speed. Okay, but if there is acceleration, then if there is air resistance, then friction forces will be also downward. So the velocity will be upward, and G plus F, the acceleration, friction, sorry, not G, since G is downward, and so this implies that weight equal to mg, that will be also downward, And 1 minute again. Sorry, I must write in this. When mass is moving upward, ball is moving upward. We will be upward, but acceleration will be due to gravity mg. That sorry, on must right, g will be downward, opposite to the velocity. Okay, and this implies that weight, that is mg, that will be also a downward, and it will reduce the uh, it will be the opposite in direction of the velocity of the ball, and it will be toward the ground or earth. So that will be also a downward, and it will resist or reduce the velocity. And similarly, if there is acceleration, because if there is a friction of the forces will be also opposite to the friction friction air resistance or friction will be also reverse to the velocity. So it means friction forces will be also a downward. Okay, friction forces will be also a downward. Okay, friction will force. So two forces, uh, W plus friction, both will be that force, both will be a downward, opposite to the opposite to the velocity to V upward, but V will be upward. So due to because this is a force is opposite, and the and due to this will resist this velocity. Okay, so maxim these two forces which are opposite to velocity, and it will force to resist ball move upward, and it will reduce maximum height of ball covered. When it will reduce the maximum height, so maximum height covered will be small as compared to if there is no resistance, no air resistance. So time taken will be small for this small cover distance. That is very important. And actually, distance is small, cover distance or maximum height is small. So it will take less time to reach this maximum height. Okay. Actually, it is a confusing question. So now I think it will be a very clear too. Okay. Now I must move toward the next question. Kilogram, the kilogram, meter, and second are the SI base unit. Straight to another SI. This is a very simple and that is the straightforward question. The current unit, that is ampere. I must write because they are asking about the unit. I must write the unit ampere. This is unit of the current. And other is Kelvin heat. Kelvin is for the heat. Kelvin for heat. Okay. So that was a very simple. Okay. Now the question is the uniform B. Question number 2, B part. Uh, B part. Okay. A uniform beam AB. Okay. 1 minute. Uniform B. Uniform. A uniform beam AB of length 6. Uh, hmm. Okay, we was trying to solve the B part of question number 2. B part. The uniform beam AB of the length 6 meter is placed on the horizontal surface. Okay, and then tilt an angle. Firstly, it is along this horizontal surface, and then tilt at angle 31, as shown in figure. Okay. Okay, the beam is held at equilibrium by 4 forces that all act in the same plane. The force of 90 Newton act perpendicular to okay, perpendicular to the beam at end A. The weight W of the beam at its center of gravity. Okay, the vertical force Y and horizontal force X both act at end of the beam. State the name of force X. X, the horizontal force, this X force at B, that will be this force X that is toward the this way. Okay. So, since this force will be this way, this is X, and this is against the motion along the horizontal surface. So, the name of this force is straightforward. That will be a friction. Friction. This will be a friction force that will be opposite to the. Okay, and B part is by taking moment about at the end B. Okay, by taking moment about and B, calculate the weight of the beam. Okay, since the point B is treating as a pivot, because rotation is about the point B. So all forces x and y at the moment of the all forces. Okay, I must write since uh, point B is acting like a since point is acting like a pivot. So all moment about moment of forces acting on B will have zero moment because moment is the perpendicular distance between the force. Okay, so because from the pivot point, because the forces acting x and y forces is passing through the B, and vertical displacement will be a zero, so that will be this force will be a, so that's why x and so the moment not forces are will be, so moment due to x and y will be zero, will be a zero. Okay, now the question is sorry. Okay, now question is by taking the moment about B, calculate the weight of the B. Okay, so there are two moment at W and moment at uh, uh, weight. Okay, so we have to calculate these two moment. Okay, so for this purpose, uh, moment at we have to calculate the moment and moment at A. What is that? That will be equal to force at A and perpendicular distance D. Because this force is perpendicular on this rod distance, so that will be equal to, yes, that will be equal to 90 multiply B. Length of the rod is given, that is 6. So 90 multiply by 6. Oh, sorry, 6. So this will be a moment at A, and moment at W point, that will be a force, weight force and perpendicular distance. Okay, so for this, we have to find the perpendicular part of this W. If this is theta, that will be theta will be equal to, this theta will be a 31. Okay, and that will be so if is okay, uh, this is W is vertical, sorry, downward. W is downward, but rod rod is rod is like this, that is 6 meter. W is downward. So if I consider that this and this is theta, sorry, again I have to consider that W is downward. Okay, okay, and if I consider that is 90 and this angle will be a 31, 31. Okay, so there will be a this perpendicular force will be a if this is a W, that will be, if this is a theta. Okay, this is theta angle. 1 minute. Theta equal to 31. I must use the small thickness. If theta is 31. Okay, so as we know that the component along the angle, that will be always equal to W cos 31, that 31, and this will be along, and horizontal component that will be along this, that will be a W sine 31, but it will be a perpendicular to this that is making angle 90. So this perpendicular, so that mean this will be a uh, W cos 31, W cos 31, and since this is the vertical displacement is one sorry, the length of rod is 6, so the length will be that length will be a 3 meter, half of. So total length is 6 W, sorry, dW will be equal to d by 2, that is 6 divided, because that is at the center, so that will be equal to 3. So here we must multiply with the 3. So both will be, because there is two movement. Okay, so due to these moment will be equal due to these. So when we consider that both are equal, so that will become since moment at A will be equal to moment at W, so that will be a 90 multiplied by 6. W cos sorry, W weight is given or not? 1 minute. Oh no, sorry, we have to calculate the weight. Weight is not given. So W cos 31 multiply 3. Okay, W will be equal to 90 multiplied by 6, 3 cos 31, and that will be equal to, after calculating, uh, that will be a 10 Newton. Okay, so W will be a the third part is determine the magnitude of force X. Very interesting. third part is find the magnitude, determine the magnitude of force X. What is the force X? Okay. Okay. To find, because force is not zero, but moment is zero. Torque is zero. Okay. Please don't confuse with that. Moment is different and torque is different. So force X is horizontal force. So so at equilibrium, horizontal component of force at A force at A will cancel it, because why uh, why the force at why forces will be, because y force at B has only vertical component and no, so so it have it has no component along horizontal. So it ha so no comp so only vertical component. So y have no horizontal component. Okay. Since only the force at equilibrium, sorry, okay, so that A will be cancelled, because at A will be cancelled because Y force at B has only vertical count. So only the horizontal. So we have to find the horizontal. So we so we have to find horizontal Mm, yeah, we may say that F A horizontal. So we have to find FA horizontal. Okay, to this purpose, okay, I must, okay, I don't know how I may lock this because, okay, this shit. Okay, so now we have to consider the horizontal component of. So this this force has sorry not direction will be downward, the direction will be upward. That is that has a two component because it is making angle 90 with this is force. This has a two component, one is vertical and one will be a horizontal. If this is angle is 31, the this is 90 Newton. Uh, I may explain it here. Okay, okay. If this is 90 Newton, okay. So it has a two component. This is 31. This is a vertical component, 90, 90 cos 31. But we have considered this. This is 90 sine 31. Okay, so horizontal component will become 90 sine 31. Okay, so only horizontal component will be considered, that will be a 90 sine 31. So the result will be a, so x will be equal to, x will be equal to, x will be equal to FA sine 31 are equal to 90 sine 31, and that is equal to 6.4 Newton. Okay, so that will be our final answer. Okay, so the this is 46.4 Newton will be your the x component of the x force. Okay, so this will be your answer. Uh, I may move it here and okay, okay. So this will be to make space for the next question. So that's why I have to. Okay, the force is so force is 46.4. Force is 46.4 newton. Okay. This for because the unit of force is newton. Okay. The principle of the conservation of for isolated system, total momentum will remain the conserve. Okay. For isolated system, total momentum sorry total momentum of system will remain conserve or constant. Conserve or constant. Okay, this conserve and constant have the same meaning. Sorry, okay, okay. The next is uh, okay. So uh, question number 3A part for isolated system, total momentum of system will remain conserve or constant. You may say that conserve or constant, both have the same meaning. Now the part B, I think I should be careful about the space. Okay, the propulsion system of toy car consists of the attached to the electric motor. Okay, these are the fans as shown in figure 3.1. Uh, Air speed is 1.8. Uh, Fins length is 0. Or diameter is 0.045 meter. Okay, the car is horizontally ground. Acha, and is initially held at rest by its brake. Okay, that is important. Firstly, it's rest at brake when motor is switched on. Okay, initially a motor was off. The rotation of the is horizontally to the left. Density of air density, that is the important. Density of air is 1.3 kilogram. Assume that assuming what is the problem? Okay, assuming that air move with the speed. Airspeed is sorry. Airspeed is this in a uniform cylinder of radius. Also assume that the air to the right of is stationary. Okay, so the air is at right is the stationary. I mean there is no speed. Okay, show that time interval 0.2 second, and that is very important. Time interval is 2 second. The mass of acha, one part b one part. Okay, the we have to find the mass. As we know that mass is always density. We know that density is equal to mass per unit volume. Okay. Sorry. So show that the interval of 2 seconds, the mass of air. So density of air will be our volume. Sorry. So volume of the cylinder for width. So firstly, we have to find the volume. Then we may find the so volume of air for 1 second or 1 or 1 second. That will be that is the cylinder, and area of circle and length. Area of circle multiply by length. That is the area of cylinder. So area of air is mean air area of air cylinder. Okay, a cylinder for 1 second. Area of circle is pi r square, as we know that pi r square, and length of cylinder is length covered in length covered in 1 second. That is given, and that is 1.8 meter. Velocity speed of air is 8 meter, 1.8 meter per second. So the 0. Radius is 0.45 meter. See, so 0.45 meter square. Length of length covered in 1 second is 1.8. Okay, so that will be a 1.8. So volume of air cylinder for 2 seconds, that will be equal to, when we multiply this 2 by 0.45 square 1.8, and that will be when we multiply that that is, after calculating, this will be equal to 0.0115 meter cube, and so this will be equal to, so from this, when we multiply with the 2 multiply by 0 sorry 2 multiply by 0.0115, that will be equal to 0.023 m cube. So okay, that will be a 0.2. Answer is 0.03 kg. Our is 0.23. Oh, this is volume. Sorry, we have to find the mass. Okay, sorry. This is a volume. Uh, no, actually, the problem is that we have to calculate the mass, not a volume. So volume. So mass. So what will be the mass of air cylinder for 2 seconds will be equal to, as we know that volume multiply by mass is density multiply by volume. So mass for 2 second, mass will be a given density multiply by air volume. in 2 seconds. Density is given. Density, mass is, density is, okay, 1.3 kilogram. This is density, okay, 1.3. So density is 1.3, and air volume we have calculated, that is for 2 second, that will be a 0 to 3, sorry, no, 0.023. Okay. 0, sorry, 0.023, and that will be become 0.030 kilogram. So that's the same. Okay. So this is true. Okay. Okay. So that the one part is solved. The second is uh, calculate the increase momentum of air in B1. We have calculated the mass. Okay. Now we have to calculate the two part is the increase in momentum of air. Okay. Uh, since initially VI V1. So since initially when the motor was stopped, the velocity, initial velocity of air was 0. Initial velocity of air Vi was 0, and the velocity of final velocity of air Vf, that was final velocity or speed, or sorry, that is 1.8, 1 point, sorry, I must 1.8, 1.8 meter, okay, meter per second. Okay, change in momentum delta P will be equal to m delta P, or m Vf minus Vi. M is 0.03. Vf was 1.8 and 0. So this will be equal to 0.03, 1.8, and that will be equal to 0.054. Okay, so that will be a change in, sorry, what is the increase momentum, Newton meter seconds. So 0.0 of 54. Okay, this is the increase in moment. This two part. This was one. two two part. The force exert on this mass air by the force of so exert on the mass of air by force of air is change in momentum. Change momentum of air change in time. Okay. So change in momentum mean delta p. Delta t change in momentum was I have already measured, that is 0 point, sorry, 0.054 divided by time was uh, 2 seconds, because force of air change in momentum, because we are calculating for 2 seconds, so that will be a for 2 seconds. So answer will be a 0.27, 0.027 Newton. Okay, so this will be 0.27, 0.027. Okay, so that will be the two part, okay, of the okay. Okay, third part is explain how Newton's third law applied to the moment of this fellow. According to Newton third law, every action has a reaction, so that will be opposite in direction. So if the motion of air is at left side, it moves the car, it force to car move at in opposite direction, means right side. Third part, as every action has its reaction in opposite direction. Therefore, air force, air force, which is toward left, force to move car in opposite direction is that toward right side. I mean, you may say that if air force is this direction, then mm, car will it will force to move the car. It is not necessarily car will start motion, but it will force to car move toward the right direction. Okay, so that will the about the third Newton third law. Okay, when Newton third law. So the fourth part is the total. Total mass of the car is 0.2 kg. Okay, no, it's about the car. Firstly, that was about the air. Now it's about the car. The total mass of the car is brake of the car are release. Acha, okay. Well, the initial velocity will be zero because car it will was there was a brake and that was car was at stationary and the car began to move at initial acceleration 0 point. Find the initial friction. Okay, so we have to find the friction. That is a very good question. Okay, as we know that sorry, net force on car will be equal to force of friction plus because there are two forces will be up net force because car will be moved toward the right side and so the net force will be and the car began to move at initial acceleration. Okay, so the net force, yeah, must write net force on car will be equal to force of friction plus force of that is force of friction and force of air. Okay, because these are the at right side and these will be at equilibrium. Fn will be equal to, sorry, I was wrong. I must write again. Fr and F air will be at toward the left side because friction will be and and sometime okay and color is not good. I think red will be good. And force car will move Fn will be and that will be toward this. Okay. Okay. So that no, sorry, I'm wrong. Sorry. I was wrong. Friction will be a negative, sorry, because friction will be opposite. Okay, friction. I should say that friction force will be inside this side, and F air will be on this side because the direction of both is opposite. F because and net force will be okay. That's yes. Friction force will be opposite direction, so that there will be a negative sign because that will be opposite in opposite direction. Okay, because it is in opposite direction. So FR is what will be the F? We have to calculate the total force is uh, total net force is equal to m a Newton. Okay, acceleration A is net acceleration, mass of the car. Okay, that is the mass of the friction. We have to calculate the friction force. And air force we have calculated already, that is 0.027 Newton. So that will be a 0.027 Newton. So this implies that Fr will be equal to uh, Fr will be moved toward so that will be equal to uh, friction force will become this will be moved toward this zero sorry 0.027 minus MAN, or you may say that 0.027 minus mass zero point 0.2 kg and acceleration 0.75. Okay, so 0.2 and 0.075. By by calculating this, that will become 0.012 Newton. Okay, this will be answer. So friction forces will be 0.012 Newton. Okay, this was the three, and this was a fourth one. Okay, now I think it's must be clear. Okay, okay. Sound wave or longitudinal wave by reference to direction of the propagation of energy state. What is the meant by the longitudinal? Acha, in the term of propagation of in the reference of the direction of propagation of the energy state, that what is the meant by longitudinal? Uh, as we know, longitudinal wave mean the direction of propagation is along the uh, along the disturbance or vibration. Okay, so I must write for a part. Oscillation direction will be parallel to the direction of propagation of the energy. Oscillation cut must be must, must be parallel to the direction of pro, propagation of energy or motion. ठीक है, okay, because in question that is the right in the form of energy, so that's why we write the interaction of propagation of the energy. Okay, A part. So that is solved. Okay, B part is B part. Stationary, B part is stationary. A sound a wave in air has amplitude A. Okay. In experiment, detector is used to determine A square. The variation of A was A square with this distance x. Along the wave is shown in figure 4.1a. Okay. Okay. This is amplitude. Okay. And this is displacement. Okay. Displacement. And this is uh, amplitude. Okay. Amplitude means maximum. State the phase difference between the vibration of air in particle x centimeter and vibration of air is fixed phase difference. So okay, they said the we have to find the phase difference. Okay, state the at 25 center and the 25. 25 will be round about. This is 25. 25. Still, particle as 25 centimeter, and that x is 50 centimeter. Sorry. Okay. And this is 25, and the other is difference between ax is 25 and at the 50. This is 50. Okay. That is amplitude. Okay, phase difference as this is increasing, and again that will be equal to lambda. Okay, maximum height. So phase difference must be because it is lambda and it is okay because both are maximum amplitude and repeating. So lambda phase difference will be equal to difference is lambda divided by lambda multiply 360. That will be a 360. Let's check the answer given on the sheet. So that will mm, mm, st- but answer is given on answer is 180. So this is wrong. Why this is wrong? Okay, problem is that this is not a traveling wave. This is a stationary sound wave. No, this is not only one problem. Problem is that one is that it's stationary wave. Even it is a stationary wave, the answer must be a 360. But if we look closely, this point is not a zero. There is not node, not nodes, not node. These points are not node and not anti-nodes. So these are the so these are not point. These points are not anti-node. These both points are not anti-node. So not. Must be careful about that. These 2 points are not empty nodes. They may be empty. Okay. Sorry, I'm wrong. Yes. And these are also, I should say, I should use. And even these 2 points that is looking like nodes, these are, and these points are not nodes. Why? Because here velocity, this is not zero. At nodes, this displacement will be zero. Okay. Sorry, these are antinodes. This is not antinode. Antinode. That is not maximum because this is a node. This is a node, but node because at this point, because at this point, displacement is zero. So actually problem is that this is zero amplitude. This is zero amplitude. So this is zero amplitude, and we was assuming that this is zero. Green point is not a are not nodes. So here is not displacement is zero, but that is central point. Okay. So if I draw it, so so sorry, because so this point is not but node. So because at this point displacement zero, and these are the antinodes. These 2 points are antinodes. These are the antinodes. Okay. Okay. Let me explain. If I draw this, this is like this. Okay. Okay. If I draw the stationary, because here amplitude is zero, so this is no. This point is. Let me explain. Okay, I understand this. This is this. This is actually the. This point is node. Okay, or these are 2 point are anti nodes. T nodes. The other part of this, because it has a zero displacement, so this will be like this. Okay, and we know that the distance between two nodes or antinodes, distance between two nodes and antinode is lambda by 2. Okay, or we may say that the open length, these has a, we may measure in the form of that is lambda by 4 and lambda by 4. Okay, you may calculate in this way. So always remember that distance distance between two nodes or antinodes, that is always equal to lambda, half of the lambda. That's yeah, we have studied in the theory. Okay, and and open half has lambda by 4. Okay. You may also calculate as distance between these no antinode is lambda by 2. You may take in this way, or you may take by assuming that. Or if you are assuming this lambda by 4 divide plus lambda by 4, that will be a 2 lambda by 4, that will be a lambda by 2. So that's mean the length will be half. Okay. So that is the main reason. Okay. So we have to, these are the not a traveling wave. This is stationary wave, and this and the amplitude. Actually, this amplitude is uh, here. Amplitude is zero. Amplitude is zero. So that's why these are the zero amplitude. So this is the antinode. Okay. Okay. So so the wavelength will be, because this is station. Actually, we was assuming we was confused due to this, because we have not observed this, that amplitude is zero here, not at this point. Okay, so that's why this that will be the half length, and phase difference will be, so phase difference will become lambda by 2 divided by lambda. That will be multiplied by 360. That be 360 divided by 2. That will be a 180. So that will be your answer. So phase difference will be 180. Okay, degree. That will be in a degree. Okay. You may write in the form of radian, but here the question was in the form of degree. Okay. Now the two part variable speed of the sound in air is this determine the frequency of the sound. As we know that the relation between the frequency and uh, velocity is equal to multiple of the product of the wave frequency and wavelength. So we have to find the frequency. So frequency will, this implies that frequency will be v over V over lambda. Okay. Mm, Okay. So we have to calculate the lambda. V is given. V is 330. V is 330 meter per second, and lambda is from here you have seen that 50 minus 25 divided by 2, and lambda is uh, as lambda is half of, because this length is half. 25 divided by 2, that will be 20, half of the 25. Okay. So 1 minute. Oh no, sorry, lambda is not half. That length is lambda is twice. Sorry, I said that this is lambda by 2 is equal to 50 minus 25. Okay, that is 25. This implies that this implies that lambda. Sorry, this implies that lambda will be 25 multiplied by 2. That will be a 50. So from here, frequency will become that frequency will become V is 330 divided by 50. Okay, 50. So that will be 50. That will be a 6. Okay, not this will be a 50. Sorry, the graph is in a centimeter. Centimeter. So this will be a C. We have to measure the length, or that will be equal to 50 multiplied with 10 raised to power. Then we convert it into the minus 2. Okay. 50 multiplied with 10 raised to power minus 2. 0 will be cancelled with the 0. So this will become 33 divided by 5, 10 raised to power 2. That will become 660 hertz. Okay. So your answer should be 660 hertz. Okay. 660 hertz. Okay. Third is okay. Next is determine the ratio amplitude of wave x in 25 in 20, and amplitude f x at 20, 25. Amplitude 25, it is amplitude is square. Okay, 25, this is force. Sorry, at what is the at 20 and 25. Okay, 20 and 25. We have to calculate the 20. I think 20. At 20, amplitude is I think there's mess here. I must remove some points. Well, yes. I have to find the amplitude at 20. 20, it is at 20. Around about this. At 25, this is 4. Okay. This is round about 2.6. Okay. 2.6. Okay. And but these are the square. So, okay. So, okay. Ratio will become at 20. That is 2.5. And this is a 4 because this is a square. Okay, sorry, must write a at 20 divided square and a square at uh, 25. So that was 2.6 divided by 4. This implies that a 20 and a 25 will be square root of 2.6 and 2 point, sorry, 4. So answer will be equal to 0.81. Okay, so answer will be 0.81. 0.81. Okay, move toward the next question. So next question is related to diffraction. So red light of wavelength is given this. Normally on diffraction grating spaces is this shown in figure. Okay. The second order diffraction maximum of light is angle theta in the direction of, show that the angle is the theta is 49. Okay, second order. The question is simple. Question number 5, A part. Okay. Show that theta is 49. As we know that the formula is for diffraction grating is d sine theta is equal to n lambda, and uh, n is 2, as order is given that that is equal to 2. Okay. 2 wavelength is having line nanometer to 640 nanometer. Nano mean 10 raised to power minus 9, and d line spacing is given 1.7. 1.7 10 raised to power minus 6 uh, meter, and sine theta. Okay, so this implies that sine theta it must be equal to 2 multiplied by 640 10 raised to power minus 9 divided by 1.7 10 raised to power minus 6. Okay, and so theta will be inverse of sine inverse of above, and everything is given this. So that will be equal to so theta will be a 49 degree. Okay, so this is correct. This is our result. Okay, okay. So theta will be a 49. Okay, A part is solved. Now the other part is to find the B part. What is the B? Determine the different wavelength of visible light that will also produce diffraction maxima at angle 49. Okay. The length of screen. Actually, the length of screen is constant. Okay, and maximum maximum order of maxima for red is 2. Okay, if we check the different frequency graph of the red light, the red light has a wavelength of visible light that will be produce a diffraction maximum at 49. Okay, but red light have we compared it. It is have maximum frequency and smallest wavelength. Sorry, sorry. This has a minimum frequency. Red light has the minimum frequency in visible light. Let me. Uh, Actually, the invisible light, the frequency of the red light is minimum since since in invisible uh, light can see of red is smallest. So have largest largest wave. So as as if since the length of the screen, yes, the screen length or diameter or dimension is constant. So as wavelength will be increased, n will be decreased. Number of wavelength on screen will be observed will be less. But if the wavelength is decrease, the n number will be increased. Okay. Since the next since red light has since red light lambda is largest, so for next because small lambda will be not possible. The be larger than larger than lambda uh, in visible light. Invisible light will be will not uh, will will be not possible. So next wavelength, your lambda will be small. Lambda will be small only, and n will be equal to 2 plus 1. That will be 3. That will be increased because lambda is a. So in this way, d sine theta will become uh, 3 3 lambda. Okay, but the d sine theta is given. Okay, because d sine theta is equal to uh, this is a d sine theta. Okay. Yeah. Because d is given, d sine theta is equal to 2 multiplied by 640 10 is to power 9. So uh, d sine theta will be a 2. Okay, sorry. Just to write in blue. 2 multiplied by 640 multiplied by 10 raised to power minus 9 divided by, sorry, equal to 3 lambda as from here to say from 10 is minus. So this implies that lambda will be equal to 2 sorry, lambda will be equal to 2. Lambda will be equal to 2 multiplied by 640 10 is to power minus 9 divided by 3, and that will be equal to 4.3 10 is to power minus 7. Okay, so 4.3. So answer is 4.3 10 is to power minus 7. Okay, so that will be the answer. The okay, define the volt in the form of the as we know that volt is uh, energy per unit charge, work done by the work done against the charge, work done by conservative force is defined as a potential difference. So the volt is uh, work the unit of, so potential difference is potential potential difference is work per unit charge, and work is the joule. Okay, unit of work is joule, and this is joule per coulomb. Okay, joule per coulomb will be the answer. Okay, that will be the. Okay, This is question number, I must write question number 8A. Okay. Question number 8B. Now the question number 8B. The battery of electromotive force is 7. ठीक है. Okay. The negligible internal resistance 0. Okay. In series with three components as shown in figure X, Y, and Z. Okay. Okay. Current, sorry, voltage in Z is given, and voltage across X and Y is not given. Resistance on X and Y is given, but Z or at resistance of Z is not given. Okay, resistance X is resistance इतनी, and the resistance on the filament wire Y जो है filament wire है, this has a resistance 6 ohm. The potential difference across that is 1.4. Calculate the current in the circuit. Okay, good. So, okay. So, this is, we have to consider this. Okay. We don't know what is the voltage. So, voltage across, may measure this delta V X Y, mean X and Y both. The voltage across X and Y, because voltage is dropping in Z, so that will be equal to V total, okay, given battery minus VZ. Okay. So this will be, as voltage is, battery voltage is 7 and Z voltage is 1.4. So resultant will be equal to 5.6 volt. Okay. That will be the voltage. So 5.6 here. Okay, sorry. 5.6. Okay. Okay. So this is a 5.6 V. Okay. Okay. Now the for voltage, we for current, measuring the current, we have to find the resistance. So resistance or X, Y, and we have to, that will be the, it because it is in series, so the resistance will be add. So R X plus R Y, R X is Y, R X is 5.2, R Y is 6. So total is 11.2. Okay, 11.2 ohm. Okay, so resistance will be 11.2. So I will be, since this is in series, so current will be in I will be the same, I will be passing through all the circuits. So delta V X Y V equal to IR, V equal to IR. So as we know that V equal to IR, so R is sorry, I will be equal to V delta V over R. Okay, so delta V over X and R X X Y. So that will be 11.2. Sorry, that will be a 5.6 divided by 11.2, and so the result will be equal to 0.5 ampere. 0.5 ampere. 0.5 ampere. Here is written 0.5. Okay. So current is 0.5 ampere. The next is find the resistance is at Z. Uh, as we know that or Z will be equal to Vz over I, because same I's will be passing in series. Uh, so Vz is given, that is 1.4. I is we have find I is 0.5. 0.5. So the result will be equal to what is 2.8 ohm. Okay. So that will be a 2.8. Calculate the percentage efficiency with which the battery supplies the power. Okay, percent we have to calculate the percentage. So we have to firstly battery supply the power to lamp. So we have to find the power supplied by the battery and power supplied to the lamp. Okay. So firstly we find the power battery. Okay. Sorry, what is battery? Battery power is V battery multiplied by current. Okay. Battery voltage is given, that is 7, and current I have already measured, the same current will be passing. Battery voltage is 7, current is 0.5. We have calculated it, 0.5, and so that will be a 3.5 watt. Okay. Or now the battery power of lamp. Lamp power will be I square R, because may find with the help of I square IV form, but then we have to uh, because resistance on that is lamp is 2.8. No, voltage is not given across the Y, so that's why we will use the lamp is Y. Okay, so lamp is By. Okay, and that will be I square or Y. Okay, lamp. So I is, sorry, I is 0.5 care, and resistance is 6 ohm. So resultant will be 1 point, when we calculate is 1.5 watt. 1.5 watt. Okay, this and this. So we have to percentage power, that is equal to Py divided by V battery, that is 1.5. Lamp power is this. 3.5 is 100. This will be 43%. So the efficiency will be of 43%. So answer will be of 43%. Okay. Next is mm, next is part. Okay. Fourth part is the filament. The filament wire of the lamp is made of material. अच्छा resistivity उसकी दी हुई है at the operation temperature in the circuit. Determine the filament wire value of cross section where the current length. Okay. As we know that resistivity is as we know that resistivity is given that resistivity is a 3.7 10 raised to power minus 7 that is given, but we know that resistance is we have to find the cross section area of the so we know that resistance we have already calculated the resistance, so we know the resistance अच्छा bulb ry, okay, ry will be equal to uh, uh, rho y, length y, and area y. Okay. Of so this implies that ry is equal to ay is equal to rho y l y. We have to find the length. So ay divided by ly, ay will become down. So rho y and resist r rho y is resistive and ry. Rho rho is given 3.7 10 is to power minus 7 and resistance I have measured 3 point resistance me 6 just 3.7 resistance is of y is 6 will be 6 ohm, and so result will be equal to 6.2 6.2 10 raised to power minus 8 and okay, 6 to 10 raised to power minus 8. Okay. Okay. Okay, next is, yes, we in this we have calculated. Now the question is 7. Okay, current in given by this formula state the symbol A and N. A is the area and N is number density. Okay. 7 A. A is area cross section area, and N is number of free electron per unit, number density of free electron. Or you may say that number of free electron per unit volume. Okay, that will be the N. Okay, the answer. Next is next is okay. Next is about find the wire XY linearly with the diameter of the XY with distance along the wire as shown in figure. Current Vx drift velocity is Vx. Okay, diameter D से D by 2 हो जाता है. Diameter will be shifted from D to D by 2. There is current I in the wire. Okay, at n x of the wire, the diameter is D and average disk speed is Vx. At the Y, D by 2. We can sketch the graph to show the average drift speed with position along the wire along XY. Okay. Uh, okay. Firstly, we have to understand what is the value of along x-axis, the position of position of wire, position along the wire, and along y-axis there's a drift velocity. Okay, so as we know that formula is also given on that. Okay, as we know that I is equal to a n v is velocity and drift velocity, that is e. So what you will get velocity that is v, that is directly proportional, sorry, inversely proportional to area, because this and the remaining all, if we take the constant, that is inversely proportional to the area 1 by a. Okay, so v velocity is inversely proportional to a. Okay, or you may say that this velocity, given velocity, is directly proportional to area, is because this pi r square of circle, so that will be pi r square, or you may say that pi d by 2 square, because that is in the form of diameter, so I have written it in the form of D by 2 square. Okay. So, okay. So V is, you may say that, because 2 is constant, pi is constant, you may say that V is, this implies that V is inversely proportional to D square. Okay. So, this implies that, as we are considering it along the S diameter d by acha, so speed of the free electron is Vx. Okay, so ठीक, okay, the speed is Vx. So at x 0, at x 0, at x, no, sorry, at x, that is given, the current is in wire I, the at the end of wire the diameter is 0 and the t diameter is d and the speed is Vx. Okay. So at x, the speed is Vx. Okay. And diameter is d. Okay. So graph will be Vx. Okay. And here d diameter is d. Okay. And diameter is d. Okay. Okay. When d move toward, for example, if I keep calculate at d as move toward the d by 2, okay, then Vx, because velocity will be directly proportional, so Vx will be d by 1 over d by 2 square. Not Vy will be at Vy because it is at y point. So Vy will be Vx. Okay. So that will be equal to, sorry, okay, and this will be equal to 4 by t square. Okay. If the diameter uh, with Vx is 1 d 1 over d by 2. So that will be if I consider 4 Vx. So so Vy will be 4y. So We may say that this x Vx will move toward y at point y, that will be a 4Vx. So at x, okay, so at x is Vx, at x it is Vx, and at y it will be a 4Vx. So this will be line. Okay, 4Vx. Okay, so this will be the answer. Okay. Okay. D scale. Sorry, here was a D scale. Okay. Sorry. Uh, okay. The next is question number 8. Last question. Okay. So 8, A part. In the following list of neutrino all particles that are leptons. Leptons are a basic particle. Mm, proton and quarks will be not. So proton is also a hadron, quarks no. So and leptons are the one. Lepton is basic particle and it has a spin half particle. So what the simply answer is uh, antineutrino. Okay, and positron, that is spin half particle. The electron, proton, neutron. Sorry, electron, not neutron. Electron, proton, and their. I think proton is not a okay because proton is not a basic particle. Electrons and anti and neutrino and their and positrons are the actually the leptons because they have a spin half, and electrons positron is the antiparticle of electron. So that is also and neutrinos are also also a uh, lepton. Okay. The next question is B part. Move toward the B part. Question number 8. Sorry, I think this is only B part. The stationary nucleus of this decay, the beta particle, and this K as Mg 1227 X beta minus mean they have a minus atomic number. Okay, and zero plus neutrine. Okay, so mass number will be increased by 1. 12 plus 1, so that will become 13, and there will be no change in this. Okay, sorry, and there will be no change on this. So weight, atomic weight, and so that will be 27. Okay, so nucleon number will be 13, and proton number that will be that is 27. Okay, because there will be no change, but atomic nucleon number will be increased. Okay, 1 minute. Then inversely, oppositely, nucleon number is 13. Proton number is uh, yeah. Firstly, I have read. Sorry, nucleon contains a proton and neutron, so that will be mass number. So that will be 27. Proton or electron are equal in, so that will be atomic number. So that will be a 13. Okay, next question is state the name of the interaction that gave rise to. This is called a weak interaction, weak force or weak interaction. Weak interaction, yeah, weak nuclear force. Okay, uh, weak nuclear force. Weak nuclear force. Okay, this is answer of the. Okay, third is state two possible reason why the sum of kinetic energy of the beta particle and energy of gamma rays is less than the total energy released during the uh, like, I have to write the two reasons. Okay, possible reasons. State two possible reason why the sum of kinetic energy of beta particle and less than the total energy of. Firstly, the electron neutrino has energy and X has also a kinetic energy. So number X has also kinetic energy to neutrino has also energy. Antineutrino or antineutrino is has also energy. So that's the two reasons, and that was the last question. Uh, if you have it is requested. If you have any confusion and if you need any clarity, I try to explain everything uh, with complete detail. But even if you face any confusion or some point need to clear, please mention it in the comment box. I will definitely explain it, and it will be pleasure for us to your uh, explain your answer of your question and try to uh, clear uh, your all confusions. Hopefully, I have explained each and everything in as detail as much as possible. Okay, so even if you have confused, if you are not agreed with any answers, or if you need further detail about any answer, please put the question in the comment box. I will explain it as soon as possible. Thank you and subscribe my channel. Thank you very much. Best of luck.